You may have some of these in your math set. These are called set squares, and they're right-angled triangular plates which are used to draw parallel lines or 90 degrees, or also 60 degrees, 45 and 30-degree lines. So these are the 90 degrees here, and then you got a 60-degree one over here, got a 30-degree one there, and then these are two 45 degrees. In this practical, I have an electromagnet that's releasing a ball and it's going to land on the trigger pad, and we're asked to measure the distance s accurately. So firstly, to measure distance, I'll need a meter ruler like this attached to a clamp stand. And to make sure that meter ruler is perfectly vertical, so I'll use a set square like this. The bottom part of the set square, I'm going to put it onto a horizontal table, so it's perfectly horizontal, and therefore the other side will be vertical, which I can use to make sure the ruler is vertical. Okay, then to take measurements from the bottom of the ball, I can use a set square again where I've aligned that right angle with the ruler like this, and I take a measurement over here. Okay, and then I can move it to the bottom here and measure from the trigger pad there, and if I subtract these two readings, I'll get the height s. Okay, now we asked to describe how the diameter of the cylinder can be determined without a micrometer or a vernier caliper. So I could just use a ruler and measure the diameter at the very end of the cylinder, but if I want to measure across the cylinder so that I can get an average for its diameter across, not just at the very ends, I can use two set squares like this. I can place the two set squares at either end of the across the cross section like this, take this reading and take this reading here, and then subtract those two to get the diameter at different points, and then average out. Okay, here we are asked to describe how the surface of the two glass blocks can be made parallel to each other and the distance between them adjusted. So again, I'll use a set square. First, I'll make the glass block here roughly vertical like this, and then I'll put the set square like this. I'll use another set square, and that way these two surfaces will be parallel when I line them like this. And then I can use a ruler to measure distance. If I want to increase this distance, I can just slide one of the set squares away from each other like so, and you can adjust the distance like that. Okay, set squares are also very useful for drawing parallel lines, so I can set the set square along a ruler like this and then draw a line like that, and then move it along a certain distance and draw another line, and that way I can get parallel lines at a certain distance apart from each other. Okay, we can also draw parallel lines at a certain angle as well. So for example, 30 degrees, or I can also do 60 degrees or 45 degrees if I wanted using a different set square. Okay, I'll draw the line like this, move it along, draw another line, so I get parallel lines like this. But if I wanted to make sure I have a control over the distance between these parallel lines, I need to be careful here because the ruler doesn't give the distance between the parallel lines. So for example, in this case, if the distance between the parallel lines is 7 centimeters, the distance, which is actually the hypotenuse of this triangle here, and the distance between the lines is actually the opposite, this one here. So if I would do that and use trigonometry, so sine theta equals opposite over hypotenuse. So in this case, my sine theta is 30 degrees, and my hypotenuse is 7 centimeters. So my opposite is going to be 3.5 centimeters like this. Okay, another useful instrument is a plumb line, which produces vertical lines. So if I want to check if this wall is perfectly vertical, I can hold a plumb line like this, and the distance from the wall to the plumb line should be the same if it is perfectly vertical. The plumb line is attracted towards the center of the earth, so it will always give a vertical line. Okay, a student released a dowel through the light gates. Explain how he could ensure the dowel passes through the second light gate. So in this case, if he releases that, it might go through the first light gate, but it's going to miss the second light gate because they're not aligned. So one way to fix this problem is use a plumb line like this above, just below the first light gate, and ensure that the second light gate's beam is directly under that plumb line as well. So this way, it should pass through both. But a better way to do this actually is just to use a transparent plastic tube and then just pass the dowel through that. Okay, the most common use for a plumb line in physics is to determine the center of mass of an irregular shaped object. So here we have an irregular shaped object hanging freely from one end. I'm going to attach a plumb line like this and use that to draw a perfectly vertical line, because I know the center of mass is going to be somewhere along that line, and then hang it freely about a different point and again draw a vertical line, and where those lines meet is going to be where the center of mass is. Okay, another possible use for plumb lines is in determining the angle to distant objects. So if you get a straw like this, like a drinking straw, attach a protractor to it like this, and then a plumb line at the very center like so. And then you can look through the straw and point it at some distant object. For example, if I was looking at a distant star, this angle here measured between the straw and the plumb line gives us angle from the vertical. And it doesn't have to be a star, it could be, for example, to the top of a wall, and then if I measure the distance to the wall, the horizontal distance to the wall, I could figure out the height of the wall without having to climb up the wall or measure along the wall's height. Okay, another way used for this is also just to measure the steepness of a slope. So for example, you can just put on a slope like this, and that gives us the angle of the slope.